You've heard the term edge computing tossed around in tech circles, but what does it really mean? In this video, we'll explore edge computing, what it is, how it differs from traditional cloud computing, its real-world applications, the market trends behind it, how companies are deploying it today, and why it's becoming a cornerstone of next-gen digital infrastructure. What is edge computing? Edge computing is a distributed computing paradigm that brings computation and data storage physically closer to the locations where it's needed, whether that's a self-driving car, a smart factory, or a remote oil rig. The edge refers to where things and people produce or consume that data, not some hypothetical perimeter. Edge computing emerged out of necessity, with data volumes exploding and real-time responsiveness becoming mission-critical in sectors like healthcare, logistics, and energy. Sending everything to a centralized cloud no longer makes sense. Instead, we offload processing to gateways, on-prem servers, or embedded devices. This shift isn't just about speed, it's about sovereignty, security, and scale. Edge versus cloud versus fog, understanding the landscape. Cloud computing, centralized processing and storage, usually hosted by third-party providers, Amazon, Google, Microsoft. Great for batch processing, analytics, and long-term storage. Fog computing, a middle layer between the cloud and edge. Introduced by Cisco, fog nodes might be on local area networks and provide additional computing before pushing data to the cloud. Edge computing, data is processed right where it's generated. Think smart cameras that flag anomalies in real time without needing to upload hours of footage. While fog and edge are sometimes used interchangeably, edge is closer to the device. In practice, many enterprise architectures use a mix of all three. Industry applications and use cases. Autonomous vehicles. Edge enables microsecond-level decisions in self-driving systems. A pedestrian crossing the street doesn't have time to wait on a round trip to the cloud. Healthcare. Portable devices and diagnostic equipment powered by edge compute help in instant decision-making, even during surgeries or in rural clinics. Energy and utilities. Wind turbines, smart grids, and offshore rigs deploy edge to monitor health, safety, and performance without relying on spotty connectivity. Retail. Smart shelves and AI-powered checkout systems rely on local processing to track inventory, monitor customer behavior, and reduce shrinkage. Manufacturing. Industrial IoT combined with edge compute allows for predictive maintenance, quality control, and process automation, vital for minimizing downtime. Telecommunications. Telcos are integrating edge nodes into 5G towers to enable ultra-low latency experiences, from AR/VR to remote surgeries. Military and aerospace. In combat zones or space missions, latency and security make edge computing non-negotiable. Edge hardware. What's under the hood? Edge devices can range from ruggedized micro data centers to Raspberry Pi style boards, AI accelerators like Google Coral or NVIDIA Jetson, and embedded chips in industrial machines. These devices often feature real-time operating systems, lightweight virtualization, containers versus VMs, onboard AI/ML inference engines. Edge servers are built to survive harsh environments, vibration, dust, moisture, or even space radiation. Security and privacy edge computing introduces a new attack surface. Each edge node could be a vulnerability, but it also offers a potential boost to privacy by processing sensitive data locally instead of sending it to centralized data lakes. Zero trust architecture, strong encryption, and remote attestation are essential practices in secure edge deployments. Market momentum. According to IDC, global spending on edge computing is projected to hit $317 billion by 2026. The main drivers: IoT expansion, AI workloads, and 5G infrastructure. Major players include AWS Wavelength, edge zones integrated with 5G networks, Azure Stack Edge, pre-configured hardware for on-prem edge deployment, Google Distributed Cloud Edge, AI and Kubernetes at the telco edge. Challenges: complexity. Managing hundreds or thousands of distributed nodes isn't trivial. Standardization. No single standard defines what constitutes the edge. Data gravity. Sometimes the data itself is too large to move. Lifecycle management. Patching, securing, and updating edge devices is an ongoing battle. Future trajectories: AI at the edge, models like ChatGPT running locally, federated learning, training models across multiple devices without data leaving the device, satellite edge computing. For remote geographies, satellites may become the new edge layer. Edge swarms, drones, robots, and sensors acting as a coordinated, intelligent mesh. Final thoughts. Edge computing isn't just a new tech trend, it's a paradigm shift. As bandwidth demands soar, privacy concerns deepen, and real-time requirements escalate, edge is becoming non-optional. If you're building systems that need resilience, responsiveness, or local autonomy, edge computing isn't just a nice to have, it's the new default. The edge is where the future happens. So here's the question. What's the one thing in your life you think should run at the edge instead of the cloud? Be bold. I read every comment.